Now, let's continue with the back. Two lines, we're going to be looking at parallel and perpendicular lines. And two lines are parallel if they do not intersect, as most of us know. But we also know that they have the same slope. So if you notice on this two, I'm going to highlight parallel, same slope. We have two parallel lines. If you notice the slope for the first one, it's up to, from this point to this point, up to, and to the right 3. So my slope for the first line will be 2 over 3. Now if we calculate the slope for the other line, which is parallel, it's also up to and to the right 3. So two lines are parallel if they have exactly the same slope. We can also graph them and compare to see if they're parallel or perpendicular. So that's two ways of doing it. One way is graphically graph both equations and then see if they're parallel. But it is better to compare the slope to confirm algebraically that they are. Two lines are perpendicular if they form a 90-degree angle. If you guys take your ID, and this is a 90-degree angle. If you guys notice, that's a 90-degree angle. So those two lines are perpendicular. We also know the perpendicular lines have the opposite reciprocal slope. So not just the opposite, but also flipped. So in order to determine which lines are parallel, we don't care about the y-intercept. I don't care about the y-intercept. So as soon as they say, determine which lines are parallel, go and cross out the y-intercept. That's going to help you guys focus on what you need to look at. We are going to be looking at their slope. So I want to be able to find out which ones have the same slope. This is a positive, that's a negative, so no. The ones that have the same slope is letters B and D. Why they're parallel? Because they have the same slope. Now, determine which lines are perpendicular. If it's perpendicular, they need to be the opposite reciprocal. So it needs to be flipped and one positive, one negative. Now the way I remember, if you guys notice, the way I remember what to look for, I want you guys with the red pen, I want you guys to accentuate the letters L so we know that they're parallel, the same slope. For perpendicular, I want you guys to place in red the P and the D. Because if you guys notice, perpendicular PD, that means that to be able to find perpendicular, it needs to be flipped, reciprocal, and the opposite. One positive, one negative. So we have 3 over 2. We're looking for 2 over 3. That's fine, but we need to be negative. So that's not it. The one's 3 over 4, so that's not it. I'm not going to cross out my y-axis, my y-intercept. So we have the ones that are perpendicular are those two because they are flipped, and one of them is positive, the other one's negative. So B and C. And let's go write down because they have the opposite reciprocal slope. Go ahead and try doing example number 6 and 7. See what you get, and then we can compare answers. Go and pause it. Great. For example number 6, perpendicular, we're looking for the slope that is opposite reciprocal. So it has to be flipped, one positive and one negative. So the ones that have opposite, so those have the same slope, one negative, one positive, but it also needs to be flipped. If you guys notice, this is over 1. So A and B have one positive, one negative, and their slope is flipped. 1 over 2, 2 over 1. because they have the opposite reciprocal slope. And the last one, parallel. I want you guys to, with your red pen, accentuate the two L's. So we're looking for the same slope. The ones that have the same slope, first let me get rid of the y-axis or y-intercept. The ones that have the same slope is letter A and letter D. Why are they parallel? Because they have the same slope. Now, last example, example number 8. In order to determine if a point is on the line, we can do two things. We can first do it graphically by graphing the line and see if any of those points are on the line. But much faster, we can actually plug in the values of x and y into the equation, and it should give us a true value. So for example, we have y is equal to negative 2x plus 1. Instead of the y, we're going to replace a negative 5 equals negative 2. Instead of the x will be a negative 3, and let's not forget about the plus 1. Now, I'm not going to solve it. The only thing that I want to do, I want to be able to simplify the right-hand side. That gives me 6 plus 1 is 7. Bring this down. Is that true or false? That's false. So is this point on the line? No. Let's try the next one. Y is equal to negative 2x plus 1. I'm going to plug in the values of x and y. Now be careful. The y is a negative 3. It's equal to negative 2 plus 1. But instead of the x will be a 2. We are going to multiply, so it gives me a negative 4 plus 1, that gives me a negative 1. And I'm going to bring this down, and that's actually negative 3. This is true, so is this point on the line? Yes. And the last one, x and y, I'm going to plug it in. Y is equal to negative 2x plus 1. Instead of the y will be a negative 1. Instead of the x will be a 1 plus 1. Now be very careful. The y is negative 1, the x is 1. I'm going to simplify it. So that's negative 2 plus 1 is equal to negative 1. I'm going to bring this down. Is that a solution? Yes. Is that point on the line? Yes. So the first one is now on the line. Those 2 points are on the line.